Hello, in this video we'll be factoring or learning how to factor quadratic expressions. We're starting to get into some of my favorite parts of algebra. These next couple chapters I really enjoy. So we're going to be factoring quadratic expressions in the form x squared plus bx plus c. Well, let's see what that looks like. So first of all, we're gonna work forwards, and then I consider factoring kind of working backwards from that. So imagine that we had these two binomials and we were multiplying them together. Using the box method, we would get this x squared, we'd get the 2x, the 3x, the 6, and then we would get our answer. The answer here, when you multiply two binomials, is a quadratic expression. You notice it looks very similar to the x squared plus bx plus c, x squared plus 5x plus 6. So I've written this form here down here under our answer. And the red things are the letters here. And they are the coefficients of the x squared, the x, and the constant here. So in this section, the coefficient of the x squared term is always going to be 1, and that's why it's not up here. There's nothing there. It's always going to be 1 for this section, so we're not going to worry about that now. So in this example, the a is 1, as I said. The b is 5, right? You can see it right here. Here's a 5. It's the b. It's the thing in the coefficient of the x term. And the constant, the c, is here. It's the 6. Okay? So we have this, and we're going to try to work backwards here. So we have this quadratic that looks like this here, and we want to figure out this answer. Okay, so here's a tip. This is the answer when we're trying to factor this. So let's see how we get to that point. This 6 came from the multiplication of these two things. Okay, so we're looking first to figure out what how we got c. We need to figure out what two numbers multiply to get 6. Okay, so we're looking for factors of 6. Factors of c, which is 6 in this case. Okay, and so the factors of c could be 1 times 6. They could be 2 times 3, and they could also be negative numbers. Negative 1 times negative 6, and negative 2 times negative 3. Okay, so that's how we got 6. With one of these four pairs gave us a positive 6. Okay, now how did we get this 5x? Well, it was the addition of these two terms here, which came from this 2 and this 3. Okay, so essentially they were added. Okay, so we want the factors, the 2 and the 3 that got us 6, to add up to be 5. So we want addends of b. So we'll call that, so here's factors of c. We want addends, things that add together, of b, which is 5 in this case. So which of these four pairs add up to 5? Well, that adds up to 7, and that one's 5, and that one's negative 7, and this one would be negative 5. So this is what we're looking for. Okay, so we want factors of 6 that added up to 5. Easy enough. And so then we just write out our binomial pair. Now to get an x squared, we know that we have to have an x at the front of each thing, right? Because this term came from the multiplication of the firsts, right? The firsts. So x squared is x times x. Now the last thing is the multiplication of the lasts, right? So the 6 came from the multiplication of the 2 and the 3. And then we just put a plus sign in between them. So let's see how we can do that for these problems here. So we want factors of C that add to B. Let me type that out. Alright, so we want factors of C that add to B. Now in order to figure that out, we got to know what B and C are. So in this case, remember A is 1 in all these examples, B is 11. So B equals 11 and C equals 24. Okay, so factors of 24 that add to 11. Well, factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. And I can see right here that 3 and 8 are going to multiply to be 24 and add to be 11. So once you find it, you don't actually have to go through and list all the pairs. Listing all the pairs is helpful when you can't quite figure out what numbers you're looking for, but once you see one that works, there will only be one, so use it. Okay, so we make our binomials, pair of binomials. Remember that to get r squared, we need to have an r and an r. To get 24 on the end, we needed to have an 8 and a 3. And since those are both positive, we just add them together, and our answer is this. Now, the easy way to check the answer is to box or FOIL these binomials to see if it's right. So you have r squared, you have 24, you have 3r, and 8r will be 11r. All right, let's try this one. It's a little different because there's a subtraction, a negative in there. So B equals -6 and C equals 8. Alright, so factors of 8 that will give us a negative number, so we're going to have a negative number in here at least. Now if we're going to have one negative factor to get a positive answer, they'll both have to be negative. Okay, so if one's negative, they both have to be negative, and we know we have to have a negative because B is negative. So we have -1 times -8. That would be -9. That's no good. -2 times -4. That would be -6. Perfect. So again, we write out our pair of binomial factors. Y has to be in the front of each because we need to get y squared. To get 8, we have -2 times -4. And that's it. Let's check it. Y squared, -4, -2 is 8. -4y and -2y is -6. Y. Alright, let's keep trying some here. Okay, now we have two negative numbers. So we know that B is equal to -4 and C is equal to -21. So I need factors of C that are going to be negative. Well, they're not both going to be negative because to get a negative number, one of them has to be negative, one has to be positive. To go even further, we know that when you add them together, if their sum is a negative number, we know that the bigger one has to be negative. Okay, so it could be 1 times -21. 2 doesn't work, so 3 times -7. Bingo. Second try. There we go. So, very similar to the first couple. We have our pair of binomials, so C has to go in the front of each. We have a -7. We have a +3. It does not matter whether you put the -7 here or here. It'll be the same thing. So you could have also written, if you wanted, C -7 times C plus 3. When you FOIL both of those, you'll see you get the same answer. Check it. C times C is C squared. -7 times 3 is -21. -7C, +3C is -4C. Moving on, we have a B of 9. We have a C of -36. I need a positive and a negative here. Positive has to be bigger, so let's try 18 and -2 now. We could try not 9. 1, 2, 3. How about 12 and -3? That works. Okay, so we have an N. We have an N plus 12 and an n minus 3. So n squared, negative 36, 12n, negative 3n, so that's 9n. There we go. And for our last one, this looks complicated and difficult, but it's actually the exact same thing. There's just one extra thing going on. We have an extra letter in here, but you know that to get the m, we're going to need, or to get an m squared, we're going to need the m's here. Same thing here. To get an n squared, we need to multiply whatever the coefficients are going to be. There's going to be an n and an n. So we can essentially forget about the n squared and just know that b equals 6 and c equals negative 27. Okay, the m and the n kind of have to be in their places here. So factors of 27, 9 and 3 come to mind. So 9 times negative 3 will work just fine. So we write plus 9n and minus 3n. And you can FOIL that just to double check. M squared, 9 times negative 3 is negative 27, n times n. And here's why you had to have an n in each one rather than an n squared in one of them and no n in the other, because when you do the outers and the inners of FOIL, right, the outer would be negative 3mn and the inner would be 9mn. If you had a squared here and a 1 and no n there, it wouldn't work out like this. Okay, so that's why you have to have an n in each binomial. And that's it for the video. Thanks for watching.